What is differentiation? Differentiation in calculus is the process of finding the derivative of a function which measures the instantaneous rate of change of one variable with respect to another. The derivative of a function fx is written as f prime x or dy dx.
Technique on differentiation. First one is power rule, second one is constant rule, the third one is sum and difference rule, the fourth one is product rule. Number 5 was quotient rule, number 6 is change rule. Number 7 is implicit differentiation, number 8 is linear approximation.
So first, you need to rewrite the square root. Y equal to 2x minus 1 power of 1 over 2 sine 3 minus x. And then we will use product rule. Let u equal to 2x minus 1 power of 1 over 2. And then v equal to sine 3 minus x. So next, we need to differentiate u equal to 2x minus 1 power of 1 over 2. Then we use chain rule. U equal to 1 over 2 in bracket 2 minus x, 2x minus 1 power of negative 1 over 2 in bracket 2. And then we simplify u equal to 1 over square root 2x minus 1. And then we differentiate v equal to sine in bracket 3 minus x. Inside the function 3 minus x has directive negative 1. V equal to cos square bracket 3 minus x times with negative 1. So v equal to negative cos in bracket 3 minus x. Next, we apply a product rule. dy dx equal to uv plus uv. And then we substitute the value. dy over dx equal to 1 over square root 2x minus 1 sine in bracket 3 minus x plus 2x minus 1 power of 1 over 2 in bracket negative cos in bracket 3 minus x and close the bracket. So the final answer is dy dx equal to sine in bracket 3 minus x over square root 2x minus 1. And then we minus square root 2x minus 1 cos 3x minus x.
For question 1b, I will show you how to differentiate the function of this question. Since this function is a fraction where both numerator and denominator contain x, we use the quotient rule, that is y equal to uv minus uv over v squared. The first thing is to identify the numerator and denominator. Let u equal to ln 5x plus 1 and v equal to cos 2x. For the numerator, u equal to ln 5x plus 1. To differentiate this, I use the rule for natural log, that is d over dx square bracket ln ax plus b square bracket equal to a over ax plus b. So the derivative is u equal to 5 over 5x plus 1. Now for the denominator is v equal to cos 2x. The derivative of cos theta is negative sine theta and the derivative of the inside 2x is 2. So the derivative becomes v equal to negative 2 sine 2x. Then I will substitute everything into the equation. That is y equal to 5 over 5x plus 1 cos 2x minus ln 5x plus 1 negative 2 sine 2x over cos square 2x. At this point, I simplify the second term, so the numerator becomes 5 cos 2x over 5x plus 1 plus 2 ln 5x plus 1 sine 2x. So the final derivative is y equal to 5 cos 2x over 5x plus 1 plus 2 ln 5x plus 1 sine 2x over cos square 2x.
So given question 2 is find dy dx for this equation by using implicit differentiate. So for the first step is we need to differentiate both sides with respect to x. So we apply d over dx to every term in the equation. So in the equation it has 4 terms here. So first of all, we need to be careful with the product rule and the chain rule, especially when differentiating terms involving y, as we must multiply by dy dx. So for the first term, 2y ln 4x, we need to use the product rule. So let u equals to 2y and v equals to ln 4x. After we get the derivative, so it's 2 ln 4x dy dx plus 2y over x. And for the second term is to use the power rule. So 3x power 7. The 7 bring 2 forward, multiply to 3, it turns into 21, and the power minus 1, so it turns to 6. So for the third term, we need to use the chain rule. So 2 tan x minus y equals to 2 sec square x minus y multiply to d over dx x minus y. And x minus y, it turns into 1 minus dy dx. After the simplifications, so the final derivative is 2 sec square x minus y minus 2 sec square. For the final term, we use the chain rule also. So e x to e power x square 2x e power x square. For the step 3 is to substitute the derivatives back into the equation. So we substitute all the differentiated terms back into the original equation from step 1. After we substitute all the derivatives, and for the second step is to isolate the terms with dy dx. Now we need to get all the dy dx terms on one side. Let's say we use the left side and all the terms on the other is to the right. After we isolate the derivative terms, and for the step 5 is to factor and solve for dy dx. So we need to factor out the dy dx on the left side and the other terms on the right side. So finally divide both sides by the term in the parentheses.
So I'm going to explain how to use linear approximation to estimate the value of square root 63.98 minus 4 over 63.98 square root of 3 correct to 3 decimals. First step is we are going to determine the fx. We know that fx is equal to the square root of x, so we assume that x is equal to 63.98. The second step is we need to find the suitable value of x and delta x. Given formula is x equal to x plus delta x. We know that x is 63.98, so we assume that x plus delta x is 64 plus minus 0.02. We to differentiate the fx. Here we have f prime x equal to 1 over 2 square root x. Step 4 is f bracket x equal to f bracket 64. f64 that we can assume that it is square root of 64. And therefore, square root of 64 is 8. Then the next one is f prime x equal to f prime 64. Then we use the formula from the step 3 into step 4 to find the prime, which is 1 over 2 square root 64 square root of 2. We get the 1 over 16. So for step 5, we need to substitute all the related values into the formula. Given formula is f bracket x plus delta x, approximately value to f bracket x plus prime f x multiplied by delta x. So all the value we get earlier, we substitute into this formula where we get f bracket 64 plus minus 0.02, approximately value to f prime 64 plus f prime 64 multiplied by minus 0.02. We know that prime 64 is 8, so we substitute into here plus 1 over 16 we get from the step 4, then minus 0.02. We get 7.999. It's actually longer, but because we want it into 3 decimal places, then we get 7.99. For that, the first step is we need to determine the fx. We know that fx is equal to 1 over square root of x. So we assume that x is 63.98. So the fx is 4 over x square root of 3. The second step is we need to find the suitable value of x and delta s. Given formula is x equal to x plus delta x. We know that x is equal to 63.98 and the x is 64. D over dx bracket of 4x power of negative 1 over 3 is equal to f negative 1 over 3x. Then the power is we need to subtract it by 1. So we get negative 4 over 3x power of negative 4 over 3. So step 4 is we need to calculate the fx and f prime x. We know that fx is equal to f bracket of 64. Therefore, we 4 over 3 bracket 64 power of negative 4 over 3, we get negative 1 over 192. Then step 5, we need to substitute all the related values into the formula, which we get f bracket of 64 plus negative 0.02, approximately value to f64, we multiply by negative 0.02. The f bracket 64 we get 1 over 6 from negative 1 over 192, then we multiply it with negative 0.02. Then we get approximately value of 0.1666. 167. Therefore, we get 7.999 minus by 0.6167, we get 7.832 equal to 3 decimal places.
In conclusion, differentiation helps us to understand a basic idea to measure how quantities change. through established rules, derivative can be determined efficiently